The next video of the chapter 7.1 continued, we're going to focus mainly on domains of radical functions. But before we do this, I just want to quickly go over how we evaluate using functions. So if we look at the first few examples, we're given function f and function g. And what we're going to do is we're going to basically substitute in. Remember that this right here is a substitution for the variable inside, so x. So f of 7 is really equal to the square root of 7 plus 2. Again, you substitute it in for that x. So now we get the square root of 9, which would just be 3. So the function at 7 would equal 3. Remember, this is also kind of like a coordinate point. Your input is 7, the output is 3. And remember that f or g denotes what function we're using. So in number 2, we're going to use the function g. So now I'm going to do the cube root of 9 minus 1, which is the cube root of 8, which happens then to be 2. Finally, we're going to do that with 10. I'm going to take the cube root of 10 minus 1, which happens to be the cube root of 9. Well, if you think about it, there is actually no number of times itself 3 times that will go, or that's an integer that will give you that. So we're going to just leave it as cube root of 9. Alright, the next thing I'm going to ask you to do is to take out your calculators, and I would like you to put into your calculators in the graphing part, so go to y equals, it's top left button, and put in the square root of x minus 1. And then in the top right corner, hit the graph button. And then take a look at what that graph looks like. It should approximately look like this. Okay? Kind of like a half rainbow starting at 1. Now, the reason why that is, if it starts right at 1, is think about this, and the last video we've done. If I have the square root of a number, what can go under here? Well, it can be any number that is not negative, right? Can't be a negative number. So what that means is it could be greater or equal to 0. So if I take what that is, x minus 1, and I go to solve that, that means that x has to be greater than or equal to, oh, sorry, this should be a 0. X should be greater or equal to 1. Therefore, that's why our graph starts at 1 for the x values. And you notice it has a value for x all the way, and it continues on forever. So without a calculator, how can we graph this? Well, I'm going to look at the domain restriction. I take whatever is underneath the radical or the radicand, and I'm going to set it greater than or equal to 0. And I'm going to solve. And from there, that becomes my x value. So x equals 1, 2, 3, 4, and then I just plug in from there. So 1 minus 1 is 0. 2 minus 1 is 1. Square root of 1 is 1. 3 minus 1 is square root of 2. And then we have square root of 3. If I did 5, we had square root of 4, which equals 2. And then you can just plot those on the graph. And you'll notice those points should be on the graph in your calculator. 1, 0. 2, 1. 3 would be approximately there. So on. And if we go to 5, 1, 2, 3, 4, 5, it would be at the number 2. It kind of levels off a little bit. And so on. It can give you a good sketch of what the graph looks like. Now, if we think about the function that's a cube root, like example number 5, we have the cube root of x plus 2. Any number can really be the radicand for a cube root because we can have negatives and positive. So the domain in anything that's a cube root could be negative infinity to infinity. So again, go to your calculators and graph this function right here. And there's a couple of things I want to point out too. When you're done graphing that, also graph the function cube root of x minus 4. So again, go ahead, pause that, and then compare the two. So these are what your two graphs kind of look like. You'll notice that the domain does go in both directions, okay, negative infinity to infinity. And you can find the points of these by basically just making a t-chart, and they would give you various points that you would be able to plot. One thing I do want to point out, though, is you'll notice the y-intercepts for both of these. For the the h function, you'll notice that it intersects at 2, okay, just like a y-intercept that you have for slope-intercept. And then the f function has an intercept at -4. The last thing I just want to emphasize is when we talk about the domain restrictions of radicals. Again, we're going to look underneath the square root sign to really establish what that is. So I take this, the 3x plus 2, and again set it equal to greater than or equal to 0. And I solve for that. So it doesn't have to be your typical binomial. I could even put that squared and solve that. But we're going to get 3x is greater than or -2, x is greater than or equal to -2/3. So again, what that would basically mean is that when you do have your radical graph, and this is kind of like that y-intercept that gets shifted down, it's going to go down to -2/3. That's going to be the farthest over that you have. So the domain, just like what we talked about in other chapters, starts right there, continues on to the right.